Hey guys, and welcome to topic 12. All right, and this chapter is the dynamic crust. This tends to be a pretty relatively difficult chapter for some students, so definitely take care in this and make sure you understand all the little nuances of the chapter, whether it be the reference table that's difficult for you or just all the wealth of information that you need to know. Alright, so first off, I show a picture of a pizza because we're going to think of the Earth as a pizza slice in one of the reference table charts that we talk about. So just remember the outer layer of the pizza is the crust, alright, and that's what we're going to start with first today. Alright, so I want to talk about two different types of crust. Okay, so there is continental, and there's what's called oceanic crust before you get to the second layer of the Earth called the mantle. Continental crust obviously refers to the layer that basically is underneath the continents, and that includes mountain ranges, so there's definitely going to be some differences between that and the oceanic crust, which is on the bottom of the ocean. All right, so let's go over the differences. So first off, so continental crust is definitely thicker. Oceanic crust is going to be thinner. All right, other things to know, and this comes from the reference table partially. We consider the continental crust mostly made of granite, so it's granitic. And oceanic crust is basaltic, mostly made of basaltic igneous rock. Okay, the densities are different because of this. Granite is around 2.7 grams per centimeter cubed, all right, the actual average density of that layer, and basaltic tends to be more dense at 3.0 grams per centimeter cubed. Okay, also other terms that you may remember from the rock chapter. Remember, granite is a lighter colored, so this is actually lighter colored material. This is darker colored because darker colored, more dense. Again, from that igneous rock chart. Okay, and then also they can couple in the terms felsic and mafic. So you remember felsic for lighter colored, mafic here, and then they can also go a step further and say what elements are dominated in these areas. So remember silicon and aluminum, and mafic means it's iron and magnesium that are dominating. Okay, so those are just all little things that they can ask with these types of crusts. So make sure you use your reference table, make sure you match up the properties of each of these things. Okay, so I just want to give you that little heads up to begin this. Very important. Okay, sorry, let me get rid of this writing. All right, so just to define a couple things also with the crust. So we know the crust already is the uppermost portion of the lithosphere. Okay, so the solid part of the Earth, the parts are always moving, and sometimes we can see it, sometimes we cannot. So direct evidence of change is seeing the ground moving during an earthquake, so that's obviously moving. Volcano erupting or lava flowing, that's going to add to the crust, so you're going to see that in multiple places in the Earth. Satellite photos, more recently, we're taking pictures of the continents as they move, and we can slowly see their movement each year. Okay, indirect would be looking at the actual layers of rock. So sedimentary rock and lava flows, igneous rock, form in horizontal layers called strata. This strata will go down in horizontal ways, so we call that original horizontality. So it's something we assume. So things will go down horizontal, and then the events will happen following that. We're going to talk more about that next chapter with geologic history. Okay, also important is that this strata can be deformed over time. So this no longer shows original horizontality. So they could be tilted over, which means they got pushed by a force on its side and ended up on an angle to the horizon. Folded, you could actually see like the crust will actually fold like a piece of paper. So you'll take the layers and they'll fold up in different ways. Okay, and that's what a fold is basically. So the rock can actually deform in that way with heat and pressure again, especially in metamorphic rock areas. Okay, faulting, we get a crack in the rock caused by crustal movements, and you can see the rock types do not match up anymore. Okay, so that's evidence of faulting. And along faults, usually earthquakes will happen typically. So that's something to watch in those areas. Okay, here is actually a fossil fish. This was found up in the Rocky Mountains. And you may ask, how did it get there? Not that the fish swam up the mountains. Okay, you might have guessed it. So that crustal movement. So fossils of the deep ocean fish have been found on tops of mountains, suggesting the crust has been uplifted or pushed upward. And also the reverse, fossils of the shallow ocean have been found at great depths. This suggests the crust has subsided or sunk in some areas. So returning back to our idea, if we go back right here, so this is the side that's uplifted, so this may end up at the top of a mountain. And then the part that sinks, this goes down further and ends up on the bottom of the ocean occasionally. So you can have faults that do both. So pretty much that's the way it works, and we'll talk more about crustal movements moving forward, earthquakes, continental drift, and all right, and that's it for today. Thank you for tuning in.